Okay, you guys there? So, let me restart this lecture recording, okay, midway here into 2.2. So, you talk to me and get on the recording if you guys have any questions, okay? So, did I talk about the first one with this class? Do you guys remember?
Yeah, you did.
I did? You wrote this down? That it holds energy?
Yeah.
Okay, and then 2, did we talk about cohesion?
Yeah.
Okay, so cohesion, is that happening on your tabletops with your models right now? Hello? Is cohesion happening on your tables? A water molecule attracted to a what? Another water molecule. Okay, then adhesion, you guys, if your water molecule is attracted to the desk, that's adhesion, right? And then this last one, solids are less dense than what? Solids are less dense than what? Liquids. Therefore, ice floats. Okay, up here, people. Okay, everybody look forward. Do you see what we're talking about here? Now, your model is on a flat surface, 2D. In the real world, water is in a 3D state, right? So as the molecules slow down, as they get colder and colder, they line up in these cool crystalline shapes. See the geometrical shapes there? Leaving lots of space for air. So this is less dense, but look at the liquid on the other side here. This liquid, you guys look at me up here, look at the examples. The water molecules are moving around and they don't have to be stuck and then separated so much. Now, do you guys remember what density means? Oh, this thing. Does anybody remember what density means?
Density is what?
So density is how much space something takes up, how much stuff is in that space. So density equals what? Mass over, good, volume. Stop playing, you guys, and listen to me. If we were going to give it units, mass, what's the unit of mass? Grams. And a typical unit we use actually, what would be for volume? Liter, but we normally do it in smaller amounts, so grams over milliliters. You need to write this down somewhere quickly. Do you guys have it written down?
Really? You got that? You sure?
Yes, I remember it. Can I go? Okay, next slide. Okay, do you guys have a place to put this? Ladies, gentlemen, face forward. You have solution definition to get in there. Then you have solvent and solute to fill in. Quickly, don't worry about the kits. Get copying in right now. Okay, here we go. Solution. Where's your paper? So the solution. This is formed when one substance dissolves into another. It's called a homogeneous mixture because it's all the same throughout. In the 2 lower boxes, solvents dissolve other substances, and in solutes, what? Dissolve in a solvent. So example, the universal solvent, this is what we've been talking about, it actually dissolves everything, given enough time, is water, H2O. These solutes right here Could be a variety of things. Okay, for example, let's just say salt or solids. Okay, now, Mr. Hager, you want to play with them?
I would love to. I'm going to give you an example, and you guys are going to tell me whether it's a solvent or a solute. Alright? So if I say water, it's a solvent. Everybody? Solvent. Now if I say Kool-Aid powder, it's a solid. It's being dissolved. Right. What does the dissolving? The solvent. No. Shake. You two sides the solvent or solute? Solid does the dissolving. Another one. What about chalk powder? Solute, yeah. It's going to be, it's the same thing dissolved into, we'll just say water. That's good.
Okay, moving on. We're going to get to acid. Oh, no, not yet. I'm ahead of myself. Okay, so here, people, you need to realize that likes dissolve likes. So let's think back, because you guys had class yesterday. Water is what type of molecule? Is it polar or non-polar? Water is polar because there's a negative side and a positive side. Okay, there are other things that aren't like that, non-polar, and the likes dissolve likes. So non-polar only dissolves non-polar things. Polar only dissolves polar. And this is mostly because polar things don't want to be near non-polar and vice versa. Now, look up here. What is on the water?
Non-polar and polar.
What do you think is on this water? Oil. Do oils and waters mix? No. What's on the top of this salad dressing? What's on the bottom? Think about it. Does anybody know? Hold on. Vinegar is a water solution. So basically it's going to behave like water. It must all be polar. Okay, ladies over here, we've got to stop and listen. Okay, now, you guys can shake up one of these Italian bottles. With your energy, you can disperse it, but still, you guys, there's oil globs in there. They don't want to mix, and you know that because when you're pouring it, it's tough to get a nice mixture on your salad out of a bottle. That's why some people have a vinegar bottle and an oil bottle, and they apply them separately, right? Okay? Now, I want you to make methane. So use your kits, use your keys, the keys on the box. Everybody make methane.